For my final video today, I wanted to walk you through how to graph one of these on the calculator and answer questions about it. I looked at all of the problems that were left, and I thought the best one to do together would be part B, and then you can complete the remaining problems as your homework for tonight. So when we look at part B, I want you guys to note that this one is a little bit more complicated than the ones we started with at the beginning of the notes. You're going to go to your calculator and go to the y equals screen, and you're going to type in the equation, -3 times 2 raised to the x minus 2 power. Now, if you have a calculator like mine where it says x minus 2 in the exponent, you can arrow out of the exponent and then put the plus 5. If, however, you do not have a calculator like mine that shows the exponent, you need to make sure you put the x minus 2 in parentheses. Now, once we do this, before you actually graph, go to your zoom button and make sure you do zoom 6, a standard window. And there it is. So from here, we can sketch this graph by going to our table, and we can graph as many points that we can get to fit without having to graph all of these decimal values. Now, what I want you to note is the farthest point on our graph, -7, appears to be very, very, very close to this value of 5. If you keep going to more negatives, you should see we are approaching this value of 5, which shows us that this is actually going to be the horizontal asymptote of this graph. Now, if you actually look at the equation, one thing I want to point out is that there is a plus 5 at the end, and this, you will learn, is always going to be your horizontal asymptote value. As you do the remaining problems, I just want you to note that whatever number you're adding or subtracting at the end becomes your horizontal asymptote. Now, going back to our graph, you guys will see that as we become more positive, we can actually graph these values. I see that there is this point right here at 0, 4.25. I see that there's a point at 1, 3.5. I see that there's a point at 2, 2. I see that there's a point at 3, -1. And then the rest of the points will go off the graph. So what we can do is we can connect these, and that is your graph. Now, to answer the questions on the side, we have to be very careful with this x-intercept. It's not a nice value. So if you guys remember, we need to go back to our graph, and we need to find this x-intercept by doing second and then the trace button. If you remember, we use option 2, the 0. So please note for this one that when we go left bound, you're trying to find where this crosses the x-axis, so left of it would be slightly above it. Hit enter. Right of it would be below the x-axis. We have to cross, hit enter, and you should see that our x-intercept for this, put it in red here, oopsies, is equivalent to approximately 2.73, we'll bump that up to a 7, 0. Now, our y-intercept for this is where we cross the y-axis, and if I'm not mistaken, I think that was 4.5, but let me hit trace and hit 0, because that'll tell me what my y-intercept value was, and I was wrong, it was 4.25. Now, again, domain doesn't matter what we're seeing with this graph. Or not seeing, apparently. That was a dumb joke. Our domain will always be -infinity to infinity. It'll be all real numbers. The range, however, depends on that horizontal asymptote. If you all notice, we are completely below our horizontal asymptote, which means our range is -infinity to 5. No bracket. You cannot equal this value. So it is very important you do not put a bracket there. Unlike what we just did with radicals where it can equal that value, here it cannot. And then finally that asymptote is equal to, change my color, y equals 5. Now, one other thing you might be asked to talk about is transformations of this function. So just going back to the original, and the final note I want to make about this is if the parent function for this was y equals 2 to the x, and that's what we graphed in the beginning, if you recall, we had this y equals 2 to the x right here. Think about the transformations we did to the parent function. Starting with the negative in the front, let's go with red. This negative right here would be a reflection over the x-axis. Note that our graph got flipped upside down, and that shows that reflection. Not only that, we see another number in the front, this 3, which would be like a vertical stretch by 3. The stretch is kind of hard to see with this graph, but what's not hard to see is the fact that this graph has also, if you look in the parentheses here, been shifted horizontally, not to the left, but to the right 2 units. Notice that the -2 is actually shifting it to the right 2 units. And then finally, that number on the outside is providing that vertical shift up 5. Kind of important to note these transformations because it practices that concept, but it's also important in understanding why our graph looks the way that it does. The final note I want to say, and then I'm done with these notes, is the whole idea of, is this growth or decay? You may be asked in the future to classify this as growth or decay, and if you look at the b value, based on what we just did in the beginning of the notes, b is greater than 1, so you would classify this as growth. However, if you look at the graph, this is a contradiction because the graph is actually decreasing left to right. Therefore, if I asked you if this was growth or decay, technically it's neither, but we could call this a reflection of growth. Think about how if we didn't reflect over that x-axis, this would actually be a growth function. Unreflect this, flip this back up, and you'll see that this is actually a growth function. But because of this negative in the front, it's causing the graph to reflect and appear like it's decreasing left to right. So just something to keep in mind. You're going to see that same thing on this graph. It's going to look like decay because this value right here tells us decay, but because it's being reflected, you'll see that this will actually be, instead of decreasing left to right, increasing. So that's all I wanted to say with the notes. I hope you understand this topic. If not, feel free to email me, but you need to make sure you complete the remaining 3 problems and submit it to Schoology by tomorrow morning, 8 a.m.